Alright, looks like we're recording. Looks like we're streaming, rather. Welcome to the weekly live stream. This is Paul. I'll be your coder this evening. You can watch me write bugs, be yelling at the screen, pointing to my mistakes. It's a mixed bag. Like I kind of look forward to it every week because it gets me focused on the live stream. Gets me focused on working on Mythruna, and so usually I'm ready to jump in right after the stream. But it does sometimes break up my Friday a little bit in a weird way. Like today, I would have been working on the fractal all afternoon, but I was like, no, I'll save it for tonight. I had some other things to get done anyway, and so I got those things done. But thanks for asking. So let's go ahead and thank the patrons. Thank you so much. Makes it feel like other people are paying attention. So if you guys follow Twitter, you know that I've been working on the world fractals and things. Oh, thank you for thanking me. So I've been messing with yeah, well, that's what we do, right? Every 1,000 lines of code is going to have a bug in it. So the quicker I can get that 1,000 lines written, the quicker I can get that bug written. So this is a picture of sort of where I've ended up with the forest fractal, or the climate fractal. I already had temperature and precipitation models, and this combines the two in such a way that I can kind of visually see where plants would grow, basically, where they would be most likely to grow. This combines it by turning temperature into kind of a bell curve where, at the far extremes, extreme heat or extreme cold, basically no plants grow at all. And then, ramping up to some plant growth based on precipitation and so on. And so from here, I can see sort of the layout of the world. This is the scale down here. So this is about 10 kilometers. Each of these little hexagons is 3 kilometers. About a day's worth of travel in Mythruna from one cell to another, daylight travel. Sort of like 12 in-game hours or 13 in-game hours. If you walked or ran. I can't remember whether it's walking or running. At any rate. So this sort of lets me see where plants would grow. This might be, sort of grasslands. There's a lot of plains in here and not a whole lot of tree growth maybe. And so then from this, in order to make this function a little better, I've created a tree fractal, sort of a forest fractal, so I can see where trees would be most likely to grow. And specifically, what I was really interested in is like where major forests would be. So these are like the thick forests that would be, hard to navigate because there's so many trees, and I really wanted them to be kind of distinct. Maybe I'll change the thresholds a little more too, so that maybe in game, this particular forest right here, which is like 1 kilometer wide, maybe the locals have an actual name for that, like the green forest or shadow forest or something, randomly generated names for different regions of trees. This indicates like rainforest, like the temperature was in the right place and the moisture is super high. So if I get to implementing jungle plants, that's where they would grow, is in these kind of areas. So this is like not a distinct forest not a set of distinct forests on its own, but just one giant region, however many, probably 30 kilometers long by 15 kilometers wide or so, this area. So that's where I was at. And then I also wanted to make sure that, like here, there are still plenty of, open space where farmlands might, be, and that was something that was not true in all. I messed with this fractal all week. Over the weekend, this last weekend, I was playing with, let me see where the state of the engine is. I don't remember where I left it. I was playing with better terrain determination using terrain roughness and some other things so that trees didn't plant in such weird places, and dirt and grass showed up in places that were only logical. And I added some different stone blocks. They don't generate yet, and some ice blocks. Maybe we'll see some of that. I don't know. So let me see where I left things. So we're standing on top of a cliff. Yeah, so see, I was playing with forests. Actually, this is a pretty good time of day, so let's just pause right there. So I was playing with forests, and this is when it was super thick, and I was trying to find rainforest area. Oh, I added a to our little test wand that can generate Geffen. I also added this mode where you can click it and it'll tell you the weather for that area. So in this case, we've got it's 46 degrees here, so kind of, or 7.8 C, 46 Fahrenheit. So it's kind of cool right here. Average rainfall is average. But so we get a lot of trees. This is when I was playing with the tree fractal, and like we have too many trees. Like there's literally no clearings, which is a problem. But the terrain is cool. And so one of the things that happened with the new generation is that when it detects that there's too much of a drop here, it won't make it dirt, it'll turn it to stone. That's exactly what old Mythruna did. And so you don't get these stacks of dirt in these thin cliff walls anymore. It's always stone. You might get some dotting of dirt and a tree that'll grow. The tree growth is also smarter. It looks around to make sure that there's enough room for roots to grow. And sometimes it's not great at it. This should not have a tree here. Let's see. I have to look at it. These stone blocks should not have counted. It's supposed to have, let's see, that counts as 2, that counts as 2, 4, 5. Yeah, so this is actually, tree is not supposed to grow here. It would have needed one more dirt block in one of the corners. So there's maybe something wrong with the math there. But I just love, we could never be this high in old Mythruna. And to look out on a valley, I'll show you what it would have looked like in old Mythruna, which is kind of fun. So if we turn off, we turn down far terrain, right? So that's old Mythruna. We can bump out the render distance, and even if we could have gone up this high, this is what old Mythruna would have looked at like. There I'm already dragging frame rate down as it's pulling those in. So it's cool, right? It's neat, but it's not nearly as cool as this. Ooh, look at that. I know. I'm still amazed by it every time, and I wrote it, so hopefully everyone else will have a lot of fun with this. I hope it's kind of like a background distraction in the coolness of the rest of the game. Yes, some of the plateaus generate with still really steep cliffs, and it looks a little strange from far away, but I'm okay with it. I need to move on and work on other things. But yeah, you see there's just too many trees here, and it's not a very high climate area. So that's what I was working on this week. And so what we're going to be doing is taking the fractals that I've built and incorporating them into here so that we can see how it would change things. Yeah, that's true. I try to, there's a sort of something I learned early on in terrain generation when working with Mythruna, and that's like, if you put too many rules in and try to make it too perfect, you'll end up with something that's boring. And when possible, let randomness win, because our brains can almost always explain away something. Like maybe that tree that I found could have grown there because it started small, and whatever. We can find plausible explanations for strange things we see. Far World is one of the coolest. Yeah. Thanks. Yeah, I feel like that too. But yeah, our brains will always explain away plausible but strange things But there's nothing to there's no cure for a boring world because you put too many rules in and now it can't generate anything interesting. So yeah, that's been my mantra since 11 years ago or whatever when I started making Mythrunas. I learned quickly to err on the side of random because it's always more interesting. You get some really cool things, even if every now and then you get something that looks out of place. So let's look at, excuse me, kind of porting this weird fractal prototype crap. We can play with it a little bit in Mapper so we can see how it works, kind of. This tool has been super useful. And I spent like an hour the other night adding the the scale legend, thinking that it would be nice for screenshots so that I don't have to explain to people how big things are. But to be honest, I find it useful even just playing around with it. So this is the fractal unclipped, and you can kind of see how there's like nice little clear areas between the forests where plants would grow. And, plants will grow in all these areas, but only trees would grow in the medium to dark areas. And so you'll get sort of natural places where travel might happen. If I'm smart enough with my algorithm to have roads and stuff go between the clearings and the forests, it just makes things more interesting. If we drill in super deep here, it should regenerate a high-res image. And you can see sort of this combines the climate fractal with the forest fractal with the regular ecology fractal, which is just sort of a general, anywhere on the world you can see where soil is more likely to grow stuff and less likely to grow stuff. Anything could grow here, but it's more likely to grow in these greener areas, less likely to grow in there. So you can see planting beds and wildflowers might grow in richer areas and so on. Just to keep things interesting. And so while this is running, I can go and edit the fractal, and so we can see I can add clips back in. I can say, if it's less than 0.25, set it to 0. Oops. And then it'll regenerate. And we can see where it would actually be less than 0.25. So the rough, when determining terrain types, there's a rough classification that happens where the 100% gets divided by 4, and so 0 through 25 gets one value, and 25 to 50 gets one value, and 50 to 75 gets another value, and that's what's used to color the far terrain before we generated trees or anything else. So I try to keep my classifications within that sort of range. It all depends on how the far terrain selections and so on. So these would be places where trees would probably never grow, rarely, if ever, grow. But grass would grow and other kinds of plants might grow, but trees hardly ever. And then this one, if we do it at 0.5, then anything less than 0.5 becomes 0, and we'll see anything that's left green then is where places where trees would definitely grow quite frequently. These are the sort of thick forests. Any place that just disappeared are places where trees would grow, but rarely, a tree here or there. Whereas this is, pretty solid forest, maybe with some, you see some places it's darker where trees might be less likely to grow, but for the most part it's thick forest. And it's kind of cool that our avatar in this particular tool is a city or a town, a little town, right, with a ship in the middle of it, because you can kind of imagine here this town existing sort of in this clearing with forest all around. And I think it's kind of cool. So anyway, but I want to get the trees done. I meant to get this all done last weekend because I was, as from the last live stream, I was supposed to be working on the large scale tile generation, river propagation and stuff like that if I was working on anything, but I got stuck renormalizing the fractals and messing with that stuff, and then I discovered problems with the trees, problems with roughness, and so on. I had to fix all that. So let us get started while this regenerates again. Oh, that's yeah, we can also go over and look at like the rainforests over here. This would be where pretty much constant trees everywhere. The climate here is super high as far as precipitation. Temperature is mild. Rainforest temperature is 80 to 90 degrees Fahrenheit, like 25 to 30 C, something like that. You know, some clearings, but anyway, it's going to be cool when it's all done working. We got, you know, deserts over here. This would be a desert. Anyway, so let's get started. I need to unravel what I've done. It's kind of in a hacky prototype stage. I ended up importing the turbulence fractal over from the old map maker tool. Show you what a turbulence fractal looks like. It looks like this normally, but if you think about it as a range where you have some kind of cutoff, you can see how these are kind of like forest shapes. And so I used this as like the basis for the forest fractal to determine where trees and forests and things were. Yeah, because you can set, you can move the threshold so that they're a little sparser. And so I have some values I can play with when putting the forest stuff in. And I'm going to leave these comments out. Unraveling what I did, we kept remembering what I kept and what I got rid of. We didn't mess with weather. I did mess with, did I? Or did I straight go to noise now? I did. I go straight to noise, and I have a new fractal, the force fractal, which is the turbulence fractal. Okay. I think what I'm going to do is cut and paste this whole area into, let's see, we'll go to the world fractal factory. I can't speak. Fractal factory is hard to say. Let's make that a Java file so we can read it. Okay, so what we want to do is we want to take this forest fractal over to here. Let me make sure I'm in the right oh yeah, see there's all this code I need to clean up at some point. Yep, create default. Okay, so we should be able to come back here. And essentially all of this stuff can go away. And I think we'll rebuild it. Yeah, it's all in Git no matter what, so. Alright. So what do we want? We want to get the climate. We want this garbage. And I'll explain. I'll bring it over a bit of a time so we can explain what it's doing. So actually, that's done. I actually have that in the world fractal now. So do I ever need T? No. Alright, so we'll get T. So they get the temperature, which we'll call T. And instead of getting that, we'll get the adjusted temperature because it's already adjusted for height at that point. So let me talk about the math over here for those who are curious. What it's doing is it's taking the regular temperature, yeah. So it's taking the temperature, which is, you know, normal fractal that spans the whole world, and will give us a range 0 to 1, which means minus 20 to 50 degrees Celsius. You know, in freedom units, that's about minus 4 to 122. And knowing sea levels at 128 meters and the tree line, sort of above which trees should not grow, we calculate sort of a range of, you know, where we are relative to sea level over that tree line. So we'll end up with a 0 to 1 where we are between 0 to tree line, or potentially over 1, right? And so then we have a baseline height, which we say above 0.2, which in this model, 0.2 times 490, 0.2 times 490. So above 98 meters is when height starts to affect temperature. As we get higher, temperature goes down, right? As you get up into the mountains, things get cooler, no matter what your average temperature is for that region. So if our height is above that baseline height, then we calculate sort of what percentage of, you know, we are between that and 1, and we adjust our temperature down by that amount. So basically 0.4 of the height effect. There's some math that determines this. It's like, what is it? Yeah, I mean, I looked all this up and I found the math, and then I adjusted it because in Mythruna the maximum height is like 640, and in the world the maximum height is like 12,000 meters. And so, you know, I adjusted it based on that. So it's pretty aggressive. Temperature goes down as you go up, and eventually if you get to the mountaintop, it's pretty much always below freezing. And so that's what this is, getting adjusted temperature, is a standard way of taking the height and the sea level temperature and turning it into an adjusted temperature. Long story short, the next thing we get is an adjusted weather. I believe we may not adjust the weather here. No, we do, right here. So we'll get the adjusted weather. So let's come over here, double W. Temperature, get adjusted weather. And the adjusted weather also takes temperature. And the reason is because we use the base weather, which is sort of the, you know, fractal based weather, and we intersect it with temperature in such a way that if our temperature is over 0.857 relates to about 40 degrees Celsius, above which should be a desert, right? On Earth, somewhere above 40 degrees is usually a desert. So what we do here is, no matter what the precipitation is locally, we'll assume that that precipitation is not staying around if the temperature is really high. And so we, as it approaches 1, we make the effective weather approach 0, basically. So at 40°C, you know, whatever the local weather is normal, but as it goes up, the effective weather goes down to the point where if you get temperature of, you know, 50°C, which is 1.0 here, then the effective weather is 0. There will be no precipitation, basically. Nothing stays around, no matter how much it rains. So that's what this is doing. And so from adjusted weather and adjusted temperature, we can calculate our climate. And how we do that is down here. And eventually I got to go back and paste all this research I did about what stuff is, blah, blah, blah. And so we have this idea. And then so let's talk about this. What we want to have happen is we want sort of a bell curve. And I don't want to have to calculate a real bell curve because that math is not fun. And I want my bell curve to be lopsided, potentially. And let me see. You know what? I didn't bring up the I didn't bring up a whiteboard this time. That's a mistake. Whiteboard.com, I think, is where we want to go. I also wish it would auto log us in, but it doesn't. So it always makes me sign up for free and doesn't know who I am. At any rate, so like if this is like, let's say we got an axis here, right, and an axis here. If this is 0 likelihood of growth and excuse me, maximum likelihood of growth, and this is 0 precipitation or 0 temperature, which is minus 20 degrees, and this is C. I'm Celsius, so and this is 50 degrees Celsius. Yeah, I'm writing with the mouse. I don't have my Chromebook up here to do the pen, but what we want is a curve that kind of looks like this, right? Where and I've drawn it poorly, but you get the idea, right? Where in the middle we have sort of maximum growth based on temperature, and towards the ends we go to 0. Like as it gets extremely cold, no growth. As we get extremely hot, no growth. And you'd normally use sort of a normal distribution or something like that to represent this. But what I did was two smooth steps divided in the middle here, if you want to think of it that way, where I've decided, between here it should smooth step between 0 and 1. Between here it should smooth step between 0 and 1 using standard, texture smooth step stuff from GLSL. It's basically a bicubic function that smoothly interpolates between 0 and 1 using some curve, right? And so I can define what temperature I want that to start happening and what temperature I want that to start happening, and on the reverse side I can define what temperature I want that to start happening and what temperature I want that to start happening. So I can define exactly where my curve sits and exactly where I start falling off. And that's what these low cut, high, mid cut 2, and high cut. So this would be, low cut, mid cut 1, mid cut 2, and high cut. And that defines my curve. You guys set? And that is, in this case, 143 is minus 10 degrees. So my low cut here is minus 10, and then the high cut is 0. So water freezes at 0, so that's below that plants stop wanting to grow. But plus or minus some amount for seasonal changes. And then the high mid cut is 25 degrees Celsius. We're starting to get warmer, right? So right in this range is where most of us live, I guess. And then the high cut is in 45 degrees, somewhere up in the desert range. Even the desert stops supporting plants. So 40 degrees is where we start to enter desert range, but above 45, no plants at all. No plants for you. So that's what that curve, that's what these values are controlling. And so from there we use the smooth step, not here. So you see and I optimize it so it's not bothering to calculate the smooth step unless it's already within that range, because it's not that it's expensive, but we are doing this a few million times, every sample, and there's a lot of samples. So here we say we have a temp factor. Yeah, so if we're less than the low cut or greater than the high cut, we're automatically 0. If we're less than the mid cut, that means we're somewhere between low cut and mid cut, and so we'll do the smooth step between low cut and mid cut 1. And if we're greater than mid cut, that means we're somewhere between mid cut and high cut, and we'll use the smooth step between high cut and mid cut because it's backwards, right? We want the curve to go backwards, and then temp factor is 1. Otherwise we're between those two values, and so it's always going to be 1. Hopefully you guys are following along. But you know what? I needed to have put this after I defined the low cut and high cut stuff. So maybe some of you were already yelling about that. So you're already writing bugs, Paul? You're still explaining what's going on. And so then to build climate, yeah, so I in the fractal I separated this out in case I wanted to scale that precipitation factor, but ultimately I chose not to. But I still can pull it out here if I want. So we've got the climate, and we've defined the climate. And if at some point I think I want to move this over, in fact, let's go ahead and do that. Let's take this and move it over into world fractal, so we can just, that way if anybody in the future is making mods and wants to redefine how the what do we call it, climate, and we'll pass these in even though we technically don't need them. What we really need, in fact I'll leave them out for now, right? We got temperature and precipitation. See if I can spell. So we'll move this over and we'll make one over here. I just learned my lesson recently that I want these in a standard place because there's lots of the layers that want to be able to query this stuff, and definitely the tree generator is going to want this. So we'll take all this stuff, kill it, put it over here. You know what, I can do like this. My editor does this cool thing. It can't re-indent on the fly, but it can do that. So we get T and W, and we will return temp factor times wetness factor. So presumably that's all there, and I didn't make a bug. I think I import fractal. Cool. So we have fractal utils. And so here we can just say climate, temperature, climate, TW. All right, so now we've got, okay. Now we got climate. That's the big green fractal we saw earlier, right? I don't think I closed it, did I? I did. So we can't look at it. Okay, so that's that. So next thing we want to steal is local ecology. So that's again the plant life, just general soil quality if you want to think of it that way. And we do have climate, so we'll adjust it by climate. So what this is saying is, do I have noise defined in a place that everybody can get at it? I don't think so. Yes, I do. Cool. Alright, so we come back up here. Oh, where am I? I've got too many things in this particular file. Where's the veg? There's veg. Okay. So in a way, vegetation here is doing a this local ecology is doing a manual combination of fractals similar to the, or manual combination of pertinent noise, similar to the way an actual fractal would do. So let me see if I can show you what's going on. I think if I come up here and I say test climate false, test local ecology true, test forest false, and we can, my best fractal demonstrator at the moment. But I want to kind of, this is again an illustration of how noise is combined to make interesting things. You know, pertinent noise on its own is already pretty interesting, but so if we come in here a little bit and let me, so we got that false, 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 true, true, false. Okay, so local ecology, so let's actually just show you one fractal. equals result 2. Oh, I'm going to have to normalize it. Comma in. Oh, I've got them spelled wrong. That's funny. Minus 2. Okay, so if I just set the local ecology to that, we get this this isn't right. Something else is going on. Did I leave something else behind? So we've only got local ecology. Let me just make sure. While we're temporarily doing things, we'll just temporarily hack some more things. Okay, so this is what that raw fractal looks like. It's basically Perlin noise stretched over 128 meter. What do you want to call it? Cycle. Anyway. So, you know, every 28 meters it enters a new cell. If you understand what Perlin noise is, that makes more sense. But this is not interesting on its own, and so we take this other fractal. Result 1 is this other fractal. So wait till this is done. You see this one's much smaller. Basically the same noise, but on a smaller scale. And then what we do is we add them together. We essentially average them into the regular one, and so that sort of combines them so that the higher frequency one affects the lower frequency one, and so you get more interesting sort of shapes. It's clearer to see if I were to threshold this by putting this threshold stuff back. So if it's less than 0.5, set it to 0, and we'll start to see what shapes we get. Yeah, I wish it was faster though. So see, this is with the two fractals combined. We're seeing everything that's above 0.5. And if I come back here and put this one back in, this is what result 1 looks like. That's sort of the 16 meter noise. Come on, you can do it. So this is 16 meter noise. And this is 128 meter noise. A normal fractal typically halves the frequencies or doubles the frequencies. So it would be the same as combining the 16 meter fractal, a 32 meter fractal, a 64 meter fractal, a 128 meter fractal. I was more interested in skipping some of the range, so rather than use a standard fractal sum or something else, I just used the two noises together and combined them myself. So this is the low frequency 128 meter noise, and we saw how they look combined together. Hopefully that makes sense, but that's what that code is doing back over here, where we're really working. And I have this in here, but I'm not using it, so I'm going to leave it out. So we take the two results. Actually, I think I already have a calculate ecology in here. Question in the chat. Thanks, Jeremy. Yeah, and be able to make custom items and clothes is what's on the horizon as well. So hopefully you guys will like that too. So I already have an ecology fractal. Let me see what the ecology fractal is doing, because maybe I can just sample that. Temperature, weather. Oh, that's what I'm defining here. Yeah, I'm screwing this up. This should be just this part. And then, we still want local ecology. And we don't want it to include all this other stuff. So actually I'm being dumb. We need to add a new fractal for forest, basically. Forest, yeah. And it's going to be 1 to 1, just same as veg. In fact, veg is 1 to 1, or 0 to 1. It doesn't matter. And turbulence is going to go into there. See, now I'm off kilter, because what I really wanted to do, this veg is supposed to be the ecology fractal. It's the raw ecology, and so it doesn't need all this other stuff. It is just what I wanted up here. So these guys go down into there. Let me just cut and paste all this. Cut and paste coding at its finest. So we do need all this here, but at that point we should be able to just say ecology equals veg get sample x, well, we'll say x comma y comma z, and so we shouldn't need any of this other crap because we're going to get that from up here, and this fractal on its own is just local ecology. In fact, we manually clamp it. If we're less than deep water, ecology is always 0. That's actually a climate thing. That's a climate thing, so we'll take that out of here. Probably then we want to keep it in, you know, we never use this in here either. So this is a function of get climate, and that's why we do want double x double y double z, just in case we need to sample another, or some implementation needs to sample another fractal. So we can return 0 if we're outside the, or not, right? We could change our mind on how we want that to work and nobody else will care. So that means we need to include that stuff in our parameters. And so that's all good. He's good. You have to pass x. Oh, and this is, yes. These are actually fractal. Yep. So I'm noticing bugs already. And we will pass XYZ in because we want to leave it up to the implementation on whether they pay attention to it or not. And I'll make sure that everybody's, because that turned out to be the bug in the old vegetation fractal, the old ecology fractals, that I was passing Y to these. That does weird things to the fractal. Interesting things, but not what I wanted for ecology. In fact, maybe it's, I don't know if it's worth showing you. If somebody wants to see it, I can show them, but I'd really just like to finish this. Okay, so we've got our local ecology, which we already could get from the thing, and then we want to do the forest. Okay, so we'll grab the forest stuff, and, well, let's take it over one at a time, because then I can explain as I go, right? We want to get sort of the forest value, which we'll get from the forest fractal. Forest. So we get, that's a forest fractal that will sample every, basically, so Mythruna kilometer, right? A 1024 meters. And from that, if we have the climate, we adjust it just slightly. So what this is saying is there's some range of values that we will, gosh, how to describe this? I want to adjust the forest value we get back from the fractal, the range of values up or down based on the overall climate. So the minimum forest we will have is whatever the current climate is times 0.5, so half of the current climate. So if we were like 100% climate, which is like best precipitation, best temperature, then the min forest we would ever have is 0.5. So everywhere is a forest, basically. So in a rainforest, everywhere is a forest because 0.5 is sort of the threshold for deep forest. And then max forest is, yeah, it turns out not to be multiplied by climate. I multiply it by 1.5 so that it goes up high enough so that that 0.5 cutoff is in a lower place, right? Is by multiplying, yeah. Anyway, just trust me that it works. I have trouble explaining it. But this moves the range moves where that 0.5 cutoff is in the fractal range based on the climate. And I probably want to spell forest correctly here or I will regret it. Okay, so then we have a forest value and next we want to then combine them all. I believe in the end, this is what I did. So what we have here is we take the forest, whatever our current forest value is, and we add to it, we plus or minus the ecology. You know, ecology is going to be between 0 and 1. So by subtracting 0.5, we make anything below 0.5 negative, anything above 0.5 positive, and so that'll sort of temper whatever the forest is, moving it up or down. So if you think about if we had a, can I move this up here? Yeah, so if we had, if you were looking at it from the side and the forest curve looked nice and slow like this, and we had an ecology curve that, looked like this, we would add that to the curve here, and we would subtract it from the curve here, and we would add it to the curve here, and we subtract it from the curve here, and we get this sort of, it follows the other fractal, right? And we multiply that all by climate so that when there is no ability to grow, nothing grows. When there's max ability to grow, we treat this the max value. And I think that's it. We take the result, we clamp it, which is what I'm doing manually there. Oh, there's this other thing. If the height is less than 0, in this case sea level, so because forest can affect the generation of underwater plant life as well. So in this case it's sea level. Sea level, do I have sea level defined? No. Ooh, but I've been checking the game constants here. But we mute it all. That's something, yeah, like big kelp forests and things like that, right? Who knows, right? But I mute it underwater, and I don't remember why I do this. I've actually picked it up from before, but I'm going to leave it in. But yeah, there could be like kelp forests, and who knows, I may use this to generate coral reefs and things as well. That my definition of ecology can expand to be whatever the game needs, right? So it doesn't have to be the real definition. So we clamp it manually, and the rest is ranges. So now we have this forest fractal. Let me make sure I can still compile before we go too further. World Fractal Factory 898. Oh, we minus a one of those. That's exactly what it was telling us too, wasn't it? Okay, we've got all kinds of problems. Height is greater than tree line, but we don't define the tree line. Somebody knows the tree line because I know we've used it elsewhere. Do I have to define it as a constant? Well, I know it's 490, so let's look up what 490 is. Snow line, tree line, where are we? Great default. So we definitely have a tree line and a snow line. So maybe I'm looking in the wrong place. Default world fractal doesn't know where tree line is. That would be true. Yeah, so we will ignore this for now. That means we're definitely going to have to do it outside. Wherever we're using climate, we'll have to be smart enough. And this guy is using climate, but he's already doing the check. Okay, so we're fine here. Yeah, those are messed up. World fractal, fractal factory, 865. It's not fractal. It is in here. We don't have it defined. Yeah, that's a problem. How was I doing this before? Who else is going to use the forest fractal? Man. We have a chicken and an egg problem because I want to pass this to default world fractal because default world fractal built in all of this adjust stuff. And I can't call that from here. It's a chicken and an egg sort of problem. And there's no easy solution except for to not put the forest fractal in the world fractal. And here I'm stumped. We need to... Let me think, who all needs this? Well, so how far terrain is selected? Let me talk about why this may not be a big deal for now. I do have to solve it eventually. There's a texture atlas. What did I call it? This one. That defines how the far terrain is interpreted based on the terrain type, the terrain wetness, and the terrain foliage level that's encoded in the terrain. And so what happens is if the terrain type is 0, then we're in this column. If the terrain type is 1, then we're in this dirt column. And then I have all these reserved for different kinds of stone and then ice. And then based on the foliage level, you're in, if there's foliage level 0, you're in this area. If it's 1, you're in this area, and so on. And then within that, there's wetness level 1, 2, 3, 4, or 1, 2, 3, 4. So you get like the dried grass. So this is based purely on this does not need a separate climate fractal because it's already built on the 3 different values that go into the climate fractal. Though it is a shame that temperature is not a part of this, so we can't, anyway, excuse me. So I believe that right now the only thing that needs the forest fractal is the tree generator. So I did all that work to put this in here, but I don't need this in here. I need this over in the tree generator. So I definitely needed to have fixed the vegetation. Well, I've got that. Let me just, don't lose it for a second. Let me make sure this will compile. Let's see. Okay, so world fractal factory. Okay, I'm putting this over here for now. I need to go back and turn these into the proper constants. We're almost on to something, guys. I know I'm going to run out of time again, aren't I? So let's go over to the terrain. First, let's see if we compile. Before we start adding new bugs. Okay, we'll go over to the tree generator, and we'll currently just define this fractal straight in here. And we'll call it private sampler forest. Okay, so let's see if that compiles. I think we're going to be missing a bunch of stuff. We got noise 1, noise 2, all that garbage. We're missing sampler. Yeah, see, this is not the best place for this, but I'm trying to get this done while we're on here and not have to worry about adding a whole life cycle layer and so on. We will cut and paste. I think we only need noise 1. Yeah, we'll cut and paste noise 1 from here. Oh yeah, that's interesting. Actually, we'll just steal this part. The seed. I think the world fractal can tell us what its seed is. Nope, but we can make it. Let's see what terrain generator has access to. Does it know the seed? It gets the world fractal, does not get the seed. We have to build the seed into it. For now, I know what the seed is, so we've hard-coded the seed. Private, yeah, just hack and slash, right? Noise 1, let's say we'll make the seed 1, 2, 3 because I know that's what the seed I'm using is for my test. Oh, this should not be 1, 1. This should be 0, 1. And okay, let's see. Okay, veg is going to fail to compile. Tree line is going to fail. Yep, we don't have tree line or deep water defined, so let's do that real quick. I'm stealing more code. Gosh, like it was like I was spending so much time doing the right thing, explaining every step I went, and I end up with hack and slash in the end, so oh well. Shall we put these up here? More stuff for me to remove later. Okay, so that should work for that. What else was it complaining about? Game constants we don't have imported. Stealing code for the win, exactly. Cut and paste coding. It's always good. Game constants, tree line. So let's see if it compiles now. I know veg.t it's not going to find because I need to just get ecology from the world fractal. So we get fractal get ecology, and I believe that's it, right? World fractal get ecology. Yep, just adjusted ecology. Did we? We just want the raw ecology. Yeah, I think I need to remove a get adjusted ecology because it's not a it's not real. That was based on a mistake. Okay, so tree generator now has a forest fractal. I believe it'll compile. It's not going to use it yet, so but that's the next step. We have several layers to play with here. There's the terrain type generation. This is where we get the adjusted temperature, we get the adjusted weather. And here is another place where we would probably want the climate, which we can now get from the fractal. Get climate xp, yp, zp. So let me talk about what this is doing. And I'm sorry this is running long. Effective temperature. When a piece of terrain is generated, when you first encounter one of these 1024 by 1024 tiles, it builds that far terrain image, which has the elevations, and it encodes terrain types into there, whether it's stone. That's what I was showing you, that atlas earlier that had the sand and the dirt and grass and so on. And so we're basically calculating what goes into that, and that is later used when we generate the the column data, the 32 by 32 chunks, to figure out what terrain to start with, and it'll also do some more fractal sampling, but that's its initial thing, so that the local terrain will match the far terrain and so on and so forth. And so I want to build climate into there as well. We do not need adjusted ecology. I believe we just need ecology. Yeah, again, I'm running long. I'm running 4 minutes long tonight so far. So we just want to get the ecology. We don't need the effective weather. We probably do want to multiply it by it. Let's just use this for now. It's not going to be right. So here's what I was talking about before. I round everything. I have to fit it in 4 bits or 3 bits, 2 bits. I have to fit it in 2 bits. So I take whatever our current ecology is, and I multiply that by 3, and round it up, and then convert it to 0 to 3 basically. 2 bits of thing, and wetness 2, so the effective weather. We didn't use climate for anything, but I feel like I'm going to later, so I'll leave that there. So we do all this weird stuff here, where we pick a terrain type based on, see, we could have used climate for a lot of this. And I'm going to have to go and reconcile that with my latest climate math. And so this is coloring the far terrain and is used to color the local terrain, and really isn't used for tree generation. In tree generation, we operate on the tile. We I have all those abandoned approaches I need to remove. So we go through the tile cell by cell, meter by meter. We get the base type from the terrain. That's what we just set, whether it's dirt or sand. If it's not dirt or sand, then we skip it because you can't grow a tree there. We get the elevation from the tile. We get in case we're underwater, we get the fluid level, because fluid and water and land are tracked separately in Mythruna now. So extract the foliage level and the wetness level and all that other garbage because we were going to use that for stuff. But in the end, I just ended up sampling everything. And so here is where we want all that forest stuff. In fact, we could... I think we don't care at all about any of these anymore. I'm starting to sound like Christopher Walken. I don't believe we care at all about any of these anymore. Because we've got it all embedded now in the forest fractals over here. I could have just looked. Yeah, so we call all that stuff as part of the forest fractal. I think then we can just skip all this garbage and say grow equals forest get sample xp/p cp. So that should tell us whether we should grow a tree or not, like probability wise whether we should grow a tree or not. The foliage level was what I was using before, but now what we will do is we will use that grow factor, but we're going to want to multiply it because as it, like if you see what the old values were, I was taking the regular ecology value and taking 10% of it because the idea being is if you rolled a dice that's going to give you a value between 0 and 1, is the chance of probability, 0 being not at all, 1 being whatever. And you can see if that's above whatever your threshold is. So like if your thresholds are below, rather, if your threshold's 0.1, you have a 90% chance of not growing anything, or 90% chance of not growing anything, and that 1%, 10% chance of growing something. But the problem is, as you're sampling, you're saying, can I put a tree here? I have a 10% chance. Nah, that fails. Okay, well, let me try the one right next to it. I have a 10% chance. Nope, that one fails. I have a 10% chance. Your chance of succeeding in, in these, like say we're sampling 16 tiles here. Your chance of succeeding even at 10% at least once to put a tree in this area is very high, right? Sampling 16 times, you're probably going to hit a 10%. So you usually have to, because trees can be spaced, checking will be spaced by meter. You have to take that into consideration. A tree itself can only, every 3 meters, every 4 meters or something like that. And so you have to lower whatever your actual chances are by the fact that you're going to try 16 times or 15, 25 times, whatever it is. I think it's more like 25 times. So we can't just take the raw ecology. We have to say, so T equals grow times. We'll just guess. Actually, see, case 2. Yeah, but we saw it was wall-to-wall trees when I did this, because that's where we were in that one area, and it was wall-to-wall trees. So let's kind of do let's say there's a 5% multiplier on growth factor. There's probably a way I can calculate this, like 1/36. You know what? I didn't take statistics, so I actually don't know. But yeah, so we'll try 0.05, which might be a little high. What I'm thinking here is like 6x6. If you imagine a 6x6 grid, 36 cells. So within like a 6x6 grid, if you imagine a tree placed in the center, but we're going to try in each one of those cells. And so, we're going to sample 36 times. And so I'm just trying to think of a rough factor to reduce our grow amount. I don't know. I don't know if I'm making sense. But it always weirded me out to be multiplying by these really small numbers. But It's because we oversample areas. And this is where, based on I could just use climate for this probably. And I'm going to need to put wetness and stuff back in because apparently I used them. Oh wait, we got these out of the... Okay, hold on. What are we using? Wetness, level, temperature, yeah. So I'm going to leave these in for now, even though it's going to slow things down to sample them twice. But I don't want to mess with the tree selection. So let me talk about tree selection. So much talking, no visuals. So there's all these different types of trees that I've defined up here, and I've added a new one, in fact, the small scrub. And then this is not how I want to do it eventually. I really want to say, when I define a tree, I want to say kind of what climates it can grow in and then have these tables built out automatically. But currently I say these are the base types. If, nothing else, here's how often certain types of trees will appear in that area. If it's super arid, only this type of tree appears. If it's semi-arid, you might get these kind of trees, rocky trees, high up in the mountains trees, super cold trees where it's mostly pine that grows, and then rainforests, which currently I just have all the scrub trees, so they're tall and they don't have low branches. And so that's this code down here is selecting which sets of trees to use. But if I want this table to be more complicated than that. And so then we pick a tree and we insert the tree. And I think, let me see if we compile. We might actually get to try this. Yep. Okay, so let me remove my old world data. TileDB, WorldDB. By the way, if you ever do this to one of your worlds, it's super destructive. I just cleared the entire world database, except for the entities. It will remember where I was standing. It will remember where I was holding and any objects I placed and so on, assuming they're not in the ground now. But it's all the far terrain and everything local. Any structures I built are gone now. All right, let's see what the trees look like. Whether this works or not, thanks for sticking around with me, guys. I don't know how many are on right now. But I don't know, it's kind of fun to explain it while I go. Wow. So when it goes like this, it's nice that we have music to listen to. Okay, it's going. Those areas where we have the high plateaus, those take a long time to generate, so they make everything really slow. Anyway, I appreciate having the audience. It's nice to get to do this and explain it while I go. Sometimes it helps me keep from making mistakes. Though it very, very, very much surprised me if this works out of the box. I think if I had respawned first, we'd be in a different area that didn't have those high plateaus to generate, but we'll see. Yes, it's not doing buildings right now, so at least it's not got to do that stuff. So it remembers the time of day. Okay, so we definitely have fewer trees. Remember how solid packed the forest was here before? Let's go ahead and pause the time of day. So it's still bringing in that far terrain. Yes, see, we got like one of those plateaus over here. So let me move up higher. See, that tree is okay. It's got grass around it in the different cardinal directions, or different whatever, cardinal and diagonal directions. Try to get up here somewhere higher. Yeah, see, it takes a long time for that plateau code to generate. Especially when my CPU is running at 58 degrees and I'm doing a live stream. Yeah. Definitely should have moved to a different part of the world. So I don't actually know where we are on the map. Things should go a little faster now. So when this map comes in, I'll be able to compare it to where I am over here on this map. I think we're in here somewhere. Yeah, we're right here. No rivers in here, obviously. Although, almost looks like there's a river there. I'm pretty sure I took the river stuff out. But yeah, I think we're right. Oh, maybe I'm not. Maybe I don't know where we are. This is not. We are not where I think we are. Ah, here we are. We're in here. So yeah, these are low growth probability. So like wide open plains potentially, sporadic tree growth. And then off there we have higher tree growth. Is that? That's not what I would have thought. This is an old fractal, so I can't be sure. But like if we go, so what is it? Rubber duck just got here. So rubber duck debugging with a live flock. Yeah, exactly. The duplicated tree and the tree arrays pine, etc. was kind of funny, but too bad you can't pass tuples. Yeah, but it's like kind of a hack. It's kind of a hack in the end, because what I really want to do is just say what the probability of a pine tree is and have it just stretch out over the whole thing. I don't know much about programming, so I only understand about half of what you're doing. It's interesting to watch though. Okay, thanks. A couple at least. I love watching all the code execute. Cool. So yeah, I mean, I have to do a deeper analysis, but let's go down here and see what the raw. We can't. I don't have my tool set to sample the forest fractal yet, but we can go down here and I can click that tool on the ground and we can see, yeah, so we have reasonable temperatures, 61 degrees Fahrenheit, 16.5 C, and 33 inches average rainfall. Yeah, wetness, foliage level 1 out of 3, wetness level 1 out of 3. So yeah, this is a relatively dry, relatively low growth area. And that's what we're seeing from the trees here. What I really want to do then is go, if we are here, I want to go over into this area over here, which I know has thick forests. And so we want to move kind of east by about 16,000 meters. Wait. Yeah. Let's say that's true, so let us do that. Warp, where are we? We are 101. What is, well, let's do 20,000 because it's easier to calculate. 5289. 5289. What I'm doing is I'm looking up in that upper corner, and then same latitude 1000. That is 3 zeros, right? Yep, 689. Let's see where that puts us. Yeah, so we're still within the realm. We can still see some of where we just were. We were right over here. And if I pull up the map, we'll see. Oh, I didn't move over as far as I wanted. Maybe I miscalculated. Oh yeah, I shifted a decimal. Yeah, kind of like I needed to increment that value right there. So we're not as far over as I wanted to be, and we're going to be in the water. But you can see these dark areas are where ecology says things should grow, and those are more likely to have trees in them. Except for that Um, yeah, well, the forest fractal is paying attention to that somewhat, but all right, so let's try this again. We're still kind of in low growth area, but this is all right. And it's the other thing you have to take into consideration is that I haven't added plant life, and I had hoped to like finish so fast that we could add some plant life in, even if it was just taking the leaves from the trees and putting them around like they were plants. But when there's just nothing but flat grass, it looks a little weird. But if there was, some tall grasses and some low grasses and some flowers and some bushes, I think this would look a lot different when you have these large flat areas. All right, so let's warp again, only this time warp 1, 0, 2, 5, 2, 8, 5, 0. Wait, is that what I want? No, that's too much, right? 1, 0, 0. I should have 1, 0, 1, 7, 2, 8, 5. Let's try that. 1, 1, 2, 3, 5, 8, 5. Nope. Okay, so we moved over to another area where we got low res terrain. Where are we on the map? My math is just not right today, because I needed to move over even further. Because we're right here. You can't see our little thing. I need to make that more visible. At least we're over the ground. And if we look behind us, which is, I think that's where we want to be. Yeah, in that area, I can't tell if the tree growth is increased or not. So let's try this again. Let's add another 10,000 or so. Maybe we'll do 9, 2, 8, 5. Yeah, so I just added. Yeah, that's what it is. I am doing the math wrong, because I needed to add 10,000. Let's say add 10,000. So this would be 1, 2, 7, 2, 8, 5, and then this would be the part that'd be easier if I would readjust the coordinates to be down in the 0 to 0 origin range instead of million origin range. Uh-oh. We may have gone too far away. Oh no, we're still okay. Although I feel like I changed my Z when I didn't mean to. We are still within the range of where we were, though. We were right over here somewhere. But now we should be. Let's see, where does this correlate on our map? Is this little lake? Yeah, so we popped right over the mountains and we're over the water. So I had been going too short, and now I've gone too long. Let's at least go to some land. Let's fly over to the land. So we already start to see more trees appear over here. Higher tree density. That's not too bad. Definitely high density on that shore over there. Okay, so let's say we really want it to be like right here. So we'll hop 1, 2, 3. I wish I could just click and teleport, right? 1, 2, 3, 4. So we'll subtract 4,000 from where we are. Warp 1, 0, 2, 3. Wait, 1, 0, 2. Yeah, 3, 2, 9, 3. And then 1, 1, 2, 3, 8, 5, 0. Let's try that. Yeah, it's taking a second. Okay, where are we on the map? Alright, we're right where we want to be. Right here. A little south is where we know there's lots of info. In fact, we can pull up the climate map, I think. Yeah, raw climate. So we're right. Yeah, this is a better map to use, isn't it? Come on, Mythruna. There's still a routine that samples the current light value for wherever you are, and that's what hangs the UI from time to time, and I need to fix that before I release again because it's really painful. Alright, so we are in the middle of, and I'm not happy. I think we need to raise the probability of trees, I believe. Let's check it. Yeah, well, so foliage level is 2. We're not in rainforest territory, but we should have a, again, I can't see what the forest value is. I need to add that to my tool, and I need to build it into the world fractal, et cetera, et cetera, et cetera. So there's still some tweaking to do, but this is better already, I think. Like, this is definitely it needs to be thickened up a little bit, but that's definitely a forest. It's not as thin as the other place. But yeah, we're getting there. So that's where we are, and that's what I'm working on. And endless tweaking. You can see the tree types change as we get higher, because we're up in that upper elevation where it starts to switch over to more pine trees. And down here, we're just kind of in the general area. I wonder if I can jump across the ocean to where the rainforest would be. Let's see, that would be, if I'm here, and I want to be here, let's see, how many, you guys can't see this, but I'm using my fingers to figure out how many times 10 kilometers would take me over there. 1, 2, 3, so 30 kilometers. So let's try, while you guys are, would it be hard to make the warp tool take relative coordinates? No, in fact, it would have been a super smart thing to do. Like if I put plus or minuses in there, that would use that. But well, that's interesting. I can have the map up while I type. That's kind of cool. So what did I say? I wanted to add 30,000. So 1,053,293. I mean, really, what would be nice is if we could just click on the map and zoom away. 1, 2, 3, 5, 0. The warp tool's like kind of a dangerous tool because you can really. If there's a bird, I mean, the red blocks still appear when there's a sound playing, so there's a bird sound playing right there in that tree. And so yeah, we're moving way far away into the middle of, yeah, we don't have any point of reference for where we were. Teleporting should be something that is used sparingly in general. So we should be, for debugging, it's essential. We should be in the middle of this rainforest area, but we'll see. Yeah, see again, trees not as thick as I would have wanted them to be. So I've got some tweaking of those values to do. And you can see that sort of thing is incredibly painful because I'll go and I'll tweak the value, clear out my world, run again, see what the trees look like here. Let's see. Do it again. So the foliage level is really low here. Oh, but that's direct ecology, not the forest. Wetness is, I expected wetness to be higher, to be honest. Oh, yeah, no, I really did. Average rainfall. Yeah, I mean, okay, so that is technically, no, average rainfall should have put the wetness level up at 3. So there's a problem in the wetness level calculation, at least in this script. This is thicker forest, right? We can't see beyond 10, 20 meters. It's definitely thicker forest than we were before, but it's not thick enough. This should be, I would have expected this forest to be just generally impenetrable, basically. Like you would have to navigate your way between tree trunks to just even move around. And it's not like that at all. Right? Deep forest should be like, where's the path? How do I get through? And before I messed with this stuff, when we first were in there, that's what the forest was like. You'd go through and you'd have to like find your way between the tree trunks and under the low branches. And when trees are solid, you should be looking for pathways and clearings and things. That's the way a forest, that's the way a deep forest should be, right? Worried about what's around that next tree trunk and whether the wolves are going to get you and so on, and having to hack your way through branches to move. And that's the fun part. And you find the path and you're like, I found a path, but it turns out it's the path to the old witch's hut or whatever. You know, you just don't know. All right, well, I think, I'm not going to make you guys sit around for the next 3 hours while I tweak fractal values, but we're getting there. We're definitely closer. Maybe I do want to at least, so we got plateaus. That's one of the reasons it's taken so long. Where are those plateaus? We're looking at straight south from where we are. Our plateaus, so where does that mean we are on this map? We must be right in this area here. I almost want to wait till it finishes coming in so we can see where we are. But we're looking south. We can see some plateaus. What other landmarks do we see? Let's see. Plateaus. Is there a body of water around? I hit the light level lockup thing. Problem is, even like moving up and down, it does that. Will it be hard to? Yeah. Oh, that's the old question. Yeah. Okay, so at least the keys are stuck. Yep, I got stuck again, asking for the light level. Yep, so there is a body of water over there, and an even bigger body of water further on. So we might be... I'm going to say we are right. Yeah, so we can actually see now. We are right here on this map. And we're climbing higher and higher because the key got stuck when it locked before. So yeah, we're right here looking in this direction. Right here looking in this direction. And that's why if we look left a little bit, we see those plateaus. Yep. Which look kind of cool. Maybe the sides are a little steep, but the ridge fractal and other things definitely added a lot to the character of these plateaus. I think they're more believable than they were before, and they definitely look nicer with trees and foliage and stuff on top. Yeah, it's not generating in that yet. This is running a little behind on the train generator, on the block generator rather. So we're way up on this cliff. Man, I don't know, I get a little vertigo looking down through her boobs to see down to the ground there. We're high enough that the clip is not generating the blocks at the bottom of the cliff. That's how high we are over land. Oh, that jump. Platforming at 380 meters. But we got some cool looking ridge fractals going on in here. I don't know. I think it looks neat. I can't wait to let you guys explore this terrain. I'm trying to hack it all together this weekend, but I don't know. And I just let you know, I won't be able to do a live stream next weekend because I have a child, my teenager, who's in some high school musical stuff that's going to take my time both Friday and Saturday night, so I won't be able to do a live stream next week. So it'll be 2 weeks. I hope I'm off today. I was off today. I'm off on Monday because it's a holiday. And I'm going to see what I can get done. Ooh, that was scary. Yeah, I'm going to see what I can get done. I don't know if I'll be able to get a release out on Monday, but we're getting close. I have some bugs I have to fix before I can even let you guys even look at this much. But I'm kind of done with the trees. I'm going to tweak it some more tonight because I gotta put it down for a little while, even if it's not working tonight. I got so many other things to do. But look, that forest is pretty thick, to be fair. Not as thick as I want, but I think it's just that 0.05 that I picked out of my butt. Probably needs to be like a 0.07 or something like that. I just need to zero in on what that looks like. All right, so I'm going to start wrapping it up. We're more than a half hour over. I appreciate all you guys hanging out. The forest density, yeah, definitely. I mean, that's the part that when I was talking about the thick forest, that's supposed to be thicker. So I may have to adjust the curves on what 0 to 1 means. You know, at anything above 0.5 should be thick forest, like, again, hard to walk through, almost thick forest. And below that, between 0.25 and 0.5 should be random scattered trees like you'd find, you know, normal environments. And then below 2.5 we shouldn't get any trees at all, which we are now, in fact, getting trees in those environments. Like if yeah, I don't want to, I'm like, we're already a half hour over. I don't know if you guys want me to keep going, but I could teleport over to one of the deserts just to make sure there are no trees over there, because we've got a desert right down here, which again is 1, 2, 3 south of us, and 1, 2, 3, 4. It's about 12,000 by 12,000 below us. So let's try warping over there real quick, if I can get the math right. Warp 105.3 minus 12,000, 1041, 573. Is that right? 1041573. Yep. And then subtract another 10,000 from, well, that puts us in 90.1154. 90.1154. Or I'm going backwards. South is positive 1011.154. Right? Yeah. All right. Let's see if that puts us in the desert. Come on. Pick it up, teleporter. Yes, in fact, I can look back at my own backpack. Yeah, there we go. Where are we on the map? Oh, that's not a good sign. I'd have expected maybe at least a little. Uh-oh. Well, we're in grasslands at least. Dry grasslands. Ooh, it's kind of cool looking, actually. You guys will get to see the temporary dry grass texture. Come on. Whee! So yeah, too many trees around here. I think if I go down here, let me click where this tree, near where this tree is, and see what the fractal says. Well, foliage level 1. Wetness level 0. Yeah, there definitely should not be a tree here. There should almost be no... Like, what was the adjusted... Yeah. Yeah. So there's some tweaking to do. Yeah, we're not getting any... Just don't know how close we are to what should be desert. But I believe this is so dry, like there shouldn't even be these green areas. Come on. Oh, well, it didn't really stop to show you the grass. Okay, so see, we're like standing on dry grass. It's got some problems with repeat, and I just stole the normal maps from other things, so I haven't had a chance to do anything proper. I just kind of hacked this all in. But, you know, it's something. Yeah, so you get like the normal maps from regular grass, so they don't quite line up with the, you know, the texture. But eventually I'm going to smooth these grass edges and have, like, when you're up close, have like a hangover even for the regular grass. And so I don't want to spend too much time messing with textures that I'm just going to delete. So let's see, do we get a map yet? No. Alright, I'm going to start wrapping it up while this does it. Give you guys a minute if you want to ask any last minute questions. We're way over time. I don't think I'm going to be able to watch this video back again and annotate it with chapter markers, but I will try at some point. The issue is that, you know, I have to watch it even at double speed to watch the whole thing all the way through. So any questions, comments, last minute things to say? Yeah, there's way too many trees here. So I've got a lot of debugging to do tonight. and hopefully I'll maybe try to post some pictures tomorrow of what I get accomplished. Make sure there are still deserts and still rainforests and still frozen tundras and things as I wander around. Yeah. But yep, happy weekend to you. And I will, this kind of, I mean, if these were like African plain style trees, this wouldn't be too bad for like a steppe. We get like the trees with like the wide canopies of dryish leaves, darker green. This would be okay. Anyway, all right. Thanks, you guys, and I will see you next time. Let me. I'm gonna let that load while we do this, and we'll go to the thanks screen. Thanks for watching. Like, comment, subscribe, share with your friends. Have them like, comment, and subscribe. But all that stuff really helps engagement with the YouTube algorithm and so on. And I appreciate you guys taking the time to be with me tonight, and I will see you next time in 2 weeks. Thanks.